In 1998, researchers at Yale University developed a realistic method for testing how long HIV remains infectious in used syringes. In the summer of 2008, using a newly developed test, they began to investigate how long hepatitis C could survive in a used syringe.
The experimental procedure that we used for understanding how long HIV survives inside a syringe was one that we developed to try to replicate as closely as possible what goes on in the real world. So for this we used real strains of virus, blood inside syringes. The syringes were stored with infected blood for periods from 1 day to 6 weeks at room temperature. And then we introduced what was inside the syringes into culture that contained the uninfected blood cells that the virus would encounter if it were injected intravenously. And after 3 weeks in culture, we could see which syringes contained viable virus and which did not. We wanted to compare two different kinds of syringes that are in use by drug users. The most common kind that we find in use are insulin syringes with fixed needles that contains only about 2 microliters of blood when the plunger is fully depressed. That's 2 millionths of a liter. The second kind are syringes with detachable needles that can contain 10, 20 or more times more blood because of that void volume where the needle and the syringe attach.
We found that HIV can be alive or survive inside syringes because of its protected environment and because of the blood for very long periods of time.
With the insulin syringes, we found that we could recover virus from most of the syringes for a period of up to a week, and from a small percentage of the syringes for a period as much as 21 days after the syringes had been loaded with HIV-infected blood. With the detachable needles, we could recover live virus in most of the syringes for periods as long as 6 weeks.
We saw something among especially the drug injection population where the prevalence of HIV was way less than that of hepatitis C. So we thought it is possible that maybe hepatitis C virus, it's staying longer in these syringes, so that if individuals exchange these syringes over a couple of days, that is probably the reason why they are getting infected.
Recently, some colleagues have developed a system that allows us to replicate what we've done with HIV on hepatitis C, combining it with blood, introducing it into culture, and having the virus replicate.
This is a very novel method that we developed here, and we were very lucky that one of the investigators here in his lab, they have been able to come out with an infectious clone of hepatitis C, and that is one of the first whole genome hepatitis virus that can grow in tissue culture.
One of the things about this hepatitis C assay that we're using that's interesting is the way the virus is constructed that allows us to measure whether or not the virus is viable.
There is a luciferase gene that has been inserted into the virus. So as the virus replicates or grows in cells, it produces this gene. It's a bioluminescent gene, so it gives this color, and we could use that as the end point of the assay.
And so you have an assay that's both qualitative. Yes, the virus is growing because light's emitted. No, the virus is dead because it's not emitting light. And at the same time, you can also do it quantitatively, how much light is emitted, so that you can know whether or not a lot of the virus has survived in a particular syringe or just a little bit. What we have found doing these experiments with hepatitis C so far was rather surprising to us. We really did think that hepatitis C would survive for a longer period of time than HIV, but what we found in fact is the opposite. That in the detachable syringes, hepatitis C remains fully infectious for periods of only a week, not 6 weeks. That in the syringes with attached needles, that the virus remains infectious in most of the syringes for periods of only 1 or 2 days as opposed to 7 days, as was the case for HIV. You have two factors that are influencing infectivity, the amount of virus, and what the virus has to do in order to go from just entering the body to becoming a productive infection.
The virus, within the first couple of days, and from our experiment probably to day 3, it's highly efficient in establishing infection, so that if it gets a cell that is susceptible, it really jumps on the cell.
It seems as though hepatitis C is more infectious by about tenfold than HIV, because there's simply more hepatitis C virus in any given amount of blood than there is HIV. The average viral load for someone who's infected with HIV is about 10,000 copies per ml of blood. For hepatitis C, the viral load is on the order of hundreds of thousands, or maybe as many as 1 million. That's a situation with HIV that you only see when people are recently infected or in end-stage AIDS.